Bismillahirrahmanirrahim. Assalamualaikum and a very good day to all lecturers that watch my video presentation, especially to Dr. Siti Alia Mazjuki and Dr. Siti Asmahani Sa'an. My name is Muhammad Afiq bin Jamaluddin, and through this video presentation, I will be presenting my proposal of my final year project entitled The Utilization of Admixture and Mineral as Partial Cement Replacement in Production of Eco-Friendly Concrete. My supervisor is Dr. Nadia Ahmad Hussein. For the first part of the presentation, I will give introduction regarding my project, and after that, I will continue with the table of comparison from past researches, the gap of research, the methods that will be used throughout this project, the conclusion, and finally the future works. There are two problem statements regarding my topic. The first one is the emission of carbon dioxide due to the usage of cement in concrete production. Generally, the binder for concrete is made using ordinary Portland cement, and this binder releases carbon dioxide into the atmosphere as it is a high energy concentrated product. The usage of concrete in the construction industry will increase the percentage of carbon dioxide that will cause environmental problems. This gas causes the depletion of ozone layer and result in global warming. According to the research, greenhouse gases like carbon dioxide contributes about 65% to global warming. For the second problem segment is waste disposal problem caused by massive production of fly ash. Huge production of fly ash at power plants causing difficulties to dispose and damaging the nature. Dumping of fly ash in the open area will cause environmental problems such as groundwater infection, overturn of bulk storage and ground pollution, and result in creating multiple health diseases. There are two objectives for this project, which are the first one is to determine the mechanical and physical properties of concrete with fly ash and natural zeolite as partial cement replacement. The second one is to investigate the optimal portion replacement of fly ash and natural zeolite with cement in production of concrete. Now I will proceed with the comparison of previous research which related to my study. According to Dhaka and Roy 2015, their research incorporates fly ash and cow dung ash in partial cement replacement at range of 10, 20 and 30%. The result obtained shows that the strength of concrete is optimum at 10% replacement of fly ash. One research conducted by Yamini and Sidiraju 2016, which incorporate fly ash and nanosilica at amount of 20 and 30%. From their research, the recommended amount of fly ash is at 20%, which shows the increment of strength of concrete. Sironia et al. 2017 incorporates fly ash and glass powder in their research of partial cement replacement. Optimum amount suggested from their research is 25% of fly ash, as it shows the strength of concrete is at highest. The incorporation of natural zeolite and tuff is shown from the research made by Mohseni et al. 2017. The result from their research shows that 10% amount of natural zeolite is recommended to be incorporated in partial cement replacement. Next, research by Ahmadi and Shekarchi 2009 proved that 15% amount of zeolite is optimal to be incorporated in production of concrete. Last but not least, Joker et al. 2019 incorporates natural zeolite and crumb rubber with amount of 5, 10 and 15% natural zeolite. The highest strength of concrete that is recorded from their research is concrete with 50% of zeolite incorporation in partial cement replacement. Now we will proceed to the gap of research between my study and past study paper. In my research, I incorporate two materials as partial cement replacement, which are fly ash and natural zeolite. My research is aimed to prove the successful of these two materials incorporates together as partial semen replacement. From the past study paper that I have referred, they do not incorporate fly ash and natural zeolite together into their mixed design, but they do combine fly ash with other materials or natural zeolites with other materials. This proves that fly ash and natural zeolites can be introduced as partial semen replacement. The percentage of fly ash and zeolites that used in the mixed design also different from the past study paper. It is for me to discover whether the percentage of fly ash and natural zeolite can be more to provide higher strength of concrete. Now we will move on to the methods that will be used in this project. This is the flowchart to visualize the flow of conducting the project. The flow starts with the selection of materials. The materials that will be used in this project are aggregates that consist of coarse and fine aggregates, fly ash, natural zeolite, superplasticizer, and cement. The aggregates will undergo aggregate testing, which are Los Angeles abrasion test and sieve analysis to determine the nominal sizes of aggregates and to test the hardness of aggregates. Then, concrete mix design will be performed to determine the percentage of materials that will be used. After that, all materials will undergo mixing process. Two tests of fresh concrete will be performed, which are consistency test and compacting factor. The fresh concrete will be cast into mold and will be left for 24 hours for hardening. After the concrete is hardened, it will be demolded and immersed into a tank full of water for curing process. Curing process consists of 3, 7 and 28 days. Then the concrete will undergo hardened concrete test and ultrasonic pulse velocity at age of 3, 7 and 28 days. The result of all tests will be recorded and compared to determine the effect of fly ash and natural zeolites in partial semen replacement. In conclusion, fly ash and natural zeolites can be used as partial semen replacement for concrete. By using this alternative, not only the cost for releasing carbon dioxide can be reduced, but the waste product can also be recycled to something useful. The objective that stated in this project is not achieved yet, as it involves lab works and multiple tests to be conducted in final year project 2. So we will move to the last part of my presentation, which is the future works. So this is the planning for FYP2 and estimated time allocation to complete a certain task for this project. And it is illustrated in the Gantt chart. As we know, for the next method, we will having only for 13 weeks. So for the first week, this project will be revised to recap back all the methods and procedures that will be used. 2 weeks are allocated for selection of materials, which are on week 2 and week 3 to avoid any shortage of materials during conducting this project. All materials that have been collected will be straight away being prepared on the third week. On week 4, the process of concrete mixing will be done, as well as several tests for fresh concrete, and the result will be obtained on the same week. Then, the concrete will undergo curing process that takes 3, 7 and 28 days long, which will be covered in week 5 until week 8. Few tests for hardened concrete will be conducted when the concrete age at 3, 7 and 28 days, and also takes place on week 5 until week 8. Together with the results that will be obtained after the test has been performed. Next, on week 9 until 10, the result will be discussed together with the finalization of project. 3 weeks allocated for report writing, starting from week 10 until 12, as all lab works and results from various lab tests have been completed. The final week, which is week 13, is allocated to prepare for the presentation of FYP2. Consultation with my supervisor, Dr. Nadia, will be done throughout the whole semester. That's all for my presentation. Thank you to all lecturers that watched my video.